All right, this is number 15, chapter 7. Okay, and what we have here is a pile of snow on a slippery roof. So I am going to draw the pile of snow on a slippery roof. Here's the roof, here's the angle, and here is the pile of snow. Funny how it looks a lot like a box. Alright, let's draw a free body diagram. Because whenever you have a problem that uses forces, free body diagram is probably a really good thing. Okay, here is force of gravity, the normal force, and there's also friction. It's going to ask us the value of the coefficient. So there's friction. And you could break up the force of gravity to match the x and y axis. So we'll have the x and y axis at the value of the angle that's given. So here's x and here's y. Okay. All right, let's see what's given. We know that the theta is 34 degrees. There's an equal sign there. All right. It's asking what the coefficient of friction will be. So, part A. Really, another way to put it is, how will, if the friction force, let's look this way, if the friction force equals the same amount as the gravitational force in the x direction, then there will be zero acceleration. So let's put that down. Fr. We want the force of friction to be equal to the force of gravity in the direction. So we can write that out as the sum of the forces in the x direction equals force of gravity in the x direction, mg sine theta, minus the force of friction, which will be the static coefficient, times the normal force. All that will equal 0. It will not have an acceleration. We know that it won't have an acceleration, not because we know it, but because that's what they're asking us. They're asking us what's the necessary coefficient of static friction so that it won't move. Now I'm going to make sine theta equal to the force of friction, But instead of writing mu Fn, I'm going to do the value of Fn, the value of the normal force, which is mg cosine theta. It's the same value, same magnitude. It's just a different opposite direction. Okay. Now, when we put it like this, we see the mass doesn't matter. So the mass of the snow doesn't matter. We also see the gravity doesn't matter. If we solve sine theta over cosine theta, equals the static coefficient of friction. So that's tan theta. And you're done.